So today's lesson is 4.2 on acid-base reactions. So we've talked about neutralization reactions quite a bit. So this is when an acid and a base are combined together. That's a neutralization reaction. And the products are always a salt and water. And neutralization reactions can happen in the labs, but they also happen in the body. So this is an example of what's happening in the digestive system. So here we have the stomach, and in the stomach we have cells that release hydrochloric acid. And that acid is there to help digest food, especially proteins. It's so strong that it could eat away the lining of our digestive tract. So in order to protect our stomach, there's another type of cell in our stomach that continuously releases mucus. And this mucus basically becomes a coating, and it contains a base that neutralizes any acid that comes into contact with the wall of the stomach. So that mucus lining protects our stomach lining from that hydrochloric acid. And this is why the stomach does not digest itself. All right, another organ involved in the digestive system is this organ right here. It's called the pancreas, and it produces a base, a sodium bicarbonate solution that gets pumped into the small intestine. So after leaving the stomach, the acidic food enters the small intestine, and this sodium bicarbonate from the pancreas and from cells in the small intestine, it will neutralize the acid, all right, because we don't want that acidic solution to enter the small intestine, because the small intestine does not have that mucus coating to protect the small intestine. So an equation here that's showing what happens during the neutralization reaction in the digestive system. So we have hydrochloric acid plus sodium bicarbonate produces sodium chloride, that's the salt, plus water, plus carbon dioxide gas. All right, there is a short video here kind of summarizing what we've just talked about. It's more visual. Next, acids and bases in the environment. So natural limestone, which is calcium carbonate, it's a base used by industry, but it is also used to neutralize lakes that have been acidified by acid precipitation. And this technique is called liming. So calcium carbonate, which is CaCO3, it's a solid. It gets added to the waters of an acidic lake. So here we can see like an airplane releasing calcium carbonate into a lake. And that calcium carbonate is going to neutralize the acidic water and raise the pH of that lake water. All right, but keep in mind it's not a permanent solution to the effects of acid precipitation, because acid precipitation is continuous. So this liming process, it's not a permanent solution. All right, continuing here, looking at liming, we're looking at the pH scale. So recall that 7 is neutral. Everything less than 7 are acids. And then to the right, everything above 7 are bases. So just some common bases are like cleaners, like oven cleaner and ammonia, baking soda, and then some common acids like lemon juice and vinegar. There's battery acid here. So what we're looking at here is for liming, we can see here that an acidic lake has a pH here of about 4.5, and normal Great Lakes water has a pH of 8.5. All right, so by adding calcium carbonate to an acidic lake, calcium carbonate has a pH of about 9.8. We then get to a neutralized lake water, which is at about 6.0 pH. All right, so adding that calcium carbonate has brought up the pH level from 4.5 to 6.0. So here is the equation showing the liming process. So we have the word equation right here. So sulfuric acid plus solid calcium carbonate produces solid calcium sulfate, carbon dioxide gas, and water. Reducing emissions. So a better way to reduce acid deposition is to prevent it from forming in the first place. So sulfur and nitrogen oxides are the compounds that are responsible for the high levels of acid deposition. So sulfur dioxide, it's a major byproduct of industrial processes, and it's also a product in the combustion of fossil fuels like natural gas. So one way to reduce sulfur emissions is to remove the sulfur from the fuel before the fuel is burned. So here we're just looking at, for example, there are gas plants such as this one in Waterton, Alberta, where hydrogen sulfide has been removed from the natural gas. The byproduct of this chemical reaction is sulfur. So that's what we're seeing here. And coal mined in Alberta is actually valued for its low sulfur content. So how do they remove the sulfur from the fuel? So scientists agree that using sweet natural gas is one way to reduce emissions that produce acid precipitation. And when I say sweet natural gas, that means that the sulfur has been removed. And then we see these large yellow piles of sulfur at some natural gas plants, like we just saw in the previous picture. So this sulfur has been removed from sour natural gas before it's sent to consumers. And since sulfur emissions are one of the main causes of acid precipitation, removing sulfur from the fuel before burning it will reduce acid precipitation. Another method is sulfur scrubbing. So the coal produced in some areas of the country contains sulfur, and when it's burned, the sulfurous emissions return to Earth as acid precipitation. So to help prevent this, there's a device known as a scrubber, which is installed on the smokestacks of many industrial plants that burn coal. It's a chemical and physical process that removes sulfur compounds formed during the combustion of coal. So basically, this is a diagram showing what's happening during scrubbing. So scrubbers remove the sulfur from the smokestack before it reaches the atmosphere. So here, coal, limestone, and air are entering the furnace. And then in the final stages of scrubbing, calcium oxide, here, it's a solid, is injected into here. And it reacts with the sulfur dioxide gas to form a wet slurry of calcium sulfite. So that's what we see here, calcium sulfite. And calcium sulfite forms a sludge that gets washed away with water. And this is a really efficient process because scrubbers can remove more than 95% of the sulfur dioxide from smokestack emissions. All right, there's a couple of videos here with links, reducing acid rain, and then coal combustion and acid rain. So these couple of videos will also show how scrubbers work. And then lastly is the questions in the textbook for 4.2. They're on page 68 in numbers 1 to 4.